Hello, in this lecture we'll find out the radius of the semicircle. In the drawing we have a semicircle. PA, line segment PA is tangent to the semicircle at point A. The length of line segment PA is 6 units. Line segment PQ equals to 4 units in its length. In addition, we know that line segment PS cuts the semicircle at points Q and S. And we also know that QS equals to QC. Here, this is angle PAB that is equal to 90 degrees in size. And this is angle SQC that is also equals to 90 degrees in size. Again, our mission is to find out the radius of this semicircle. So first of all, I will present to you a new rule, rule number 10, and we'll implement rule number 10 in our drawing. According to rule number 10, in any circle, rule number 10 is true in any circle. So in any circle, if AB is a chord in the circle and PT is tangent to the circle, then the following equation is true. That PT square equals to PA times PB. Again, PT square equals to PA times PB. Okay, so actually we have the common external point P. From the common external point P, we have tangent PT that is tangent to the circle at point T. And we also have line segment PB. This line segment PB cuts the circle at points A and B. So in this drawing, the following equation is true. That PT square equals to PA times PB. Again, PT square equals to PA times PB. Okay, so actually we can implement rule number 10 in our drawing. Why? Because in our drawing we have the common external point P. From the common external point P, we have tangent PA that is tangent to the semicircle at point A. And we have also line segment PS that cuts the semicircle at points Q and S. So all the requirements of rule number 10 are met. Therefore, we can implement in our drawing rule number 10. Okay. And according to rule number 10, we get that PA square equals to PQ times PS. Repeat again. If we focus on the common external point P, we can implement in our drawing rule number 10. According to rule number 10, PA square equals to PQ times PS. So PA is 6, therefore PA square is 6 square, that is 36. And it is equals to PQ. PQ is 4 times PS. PS in total equals to PQ plus QS. That is to say PS equals to PQ, that is 4 plus QS. So in total, PS equals to 4 plus QS. So actually, we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here, we divide this equation by 4, and you get that 46 over 4 is 9, so 9 equals to 4 plus QS. Here we'll subtract 4 from this equation, and you get that QS equals to 9 minus 4, that is 5. So QS equals to 5 units in its length. Here, this 9 segment QS or chord QS equals to 5 units in its length. And because of the fact that it is given us the question that QS equals to QC and QS equals to 5, therefore QC must be also equal to 5 units in its length. The next step, I present to you rule number 3, and we will implement rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So, in the drawing we have the straight line AB. If we focus on the upper side of the straight line AB, it's point Q here. The sum of the angles on the upper side of AB at point Q must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle alpha and angle beta. So according to this rule, rule number 3, alpha plus beta must be equal to 180 degrees. We actually can implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the lower side of the straight line PS at point Q, at the lower side of PS at point Q, the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. Again, in order to complete the sum of the angles on the lower side of the straight line PS at point Q to 180 degrees, the missing angle must be equal to 90 degrees. In the next step, we join points P and C together by a straight line. By joining points P and C, we created the right triangle, triangle PQC. So I'll copy the right triangle PQC in a new page, and we will implement the Pythagoras theorem on this right triangle, triangle PQC. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle PQC that I copied from the original drawing. Side PQ equals to 4 units according to what is given as the question, and we just right now found out that QC equals to 5 units. So in this right triangle PQC by PT is the abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, PC squared, that is the square of the hypotenuse, must be equal to PQ squared plus QC squared. So PC squared must be equal to PQ squared. PQ is 4, therefore PQ squared is 4 squared, that is 16, plus QC squared. QC is 5, therefore QC squared is 5 squared, that is 25. So in total, PC squared equals to 16 plus 25, that is 41. So actually we found out that PC squared equals to 41. The square of the hypotenuse, PC squared equals to 41. In the next step, I will copy the right triangle PAC in the new page, and we will implement on this right triangle PAC the Pythagoras theorem. PA equals to 6 units according to what is given as the question. And we have already found out that PC squared equals to 41. So actually, this is the right triangle PAC that I call it from the original drawing. Again, PC squared, the square of the hypotenuse equals to 41, and PA equals to 6. So here by PT is the relation for Pythagoras theorem. So according to the Pythagoras theorem, in this right triangle PAC, PC squared, the square of the hypotenuse, must be equal to PA squared plus AC squared. PC squared is 41, so it says that PC squared by 41. That is equals to PA squared. PA is 6, therefore PA squared is 6 squared, that is 36, plus AC squared. Here we'll subtract 36 from this equation, and finally we get that AC squared equals to 41 minus 36 is 5, so AC squared equals to 5. Here we take a root out of this equation, and finally we get that AC equals to the square root of 5 units. So here the length of this line segment AC equals to the square root of 5 units. We know that this is a semicircle, and therefore AB must be the diameter of the semicircle. So I write it down here that AB is the diameter of the semicircle. So if we define the radius of this semicircle as x, I remind you that the radius of the semicircle is the radius that we are looking for in this question. So if the radius of the semicircle equals to x units in its length, then the diameter AB must be equal to 2x. AB equals to 2x. What is the length of line segment CB? From the drawing, it is very easy to see that CB equals to AB minus AC. Again, AB minus AC equals to CB. So I'll write it down. CB equals to AB minus AC. So CB equals to AB, that is 2x, that is the diameter of the circle, minus AC. We just right now found out that AC equals to the square root of 5 units. So in total, CB equals to 2x minus square root of 5 units. You can write here that CB equals to 2x minus square root of 5 units in its length. Okay, so in the next step, we will complete the semicircle to a circle. We completed the semicircle to a circle, and we will extend side QC by a straight line until it touches the circle. We will define the touching point of the extended side QC with this circle as point M. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is about two chords that intersect with each other inside the circle. According to rule number 11, rule number 11 is true in any circle. So in any circle, if chord AB, this is chord AB, intersects with chord CD, this is chord CD, it's point O. The intersection point occurs at point O. Then the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule number 11 in our drawing. Why? Because in our drawing, chord AB intersects with chord QM at point C. And whenever you have two chords that intersect with each other inside the circle, you can implement rule number 11. So write it down in our original drawing. Chord AB intersects with chord QM at point C. Therefore, we can implement rule number 11. According to rule number 11, AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. AC times CB equals to QC times CM. Repeat again, AC times CB equals to QC times CM. AC equals to the square root of 5 units times CB. CB equals to 2x minus square root of 5 units. And it is equals to QC. QC equals to 5 times CM. We will define the length of line segment CM as B. So CM equals to B according to our definition. In conclusion, we found out that according to rule number 11, square root of 5 times 2x minus square root of 5 equals to 5b. So here we will divide this equation number 1 by square root of 5. And we get that according to equation number 1, 2x minus square root of 5 equals to 5b over square root of 5. Here we will add to this equation number 1 square root of 5. And we get that according to equation number 1, two x equals to 5b over square root of 5 plus square root of 5. Repeat again. We found out that according to equation number 1, 2x equals to 5b over 5 plus square root of 5. Here we will multiply square root of 5 by square root of 5 and then we will divide it by square root of 5 in order to have a common factor with this expression. And we get that according to equation number 1, 2x equals to 5b over square root of 5 plus, here we will multiply square root of 5 by square root of 5 and then we will divide it by square root of 5, so we change nothing, therefore this operation is allowable. In conclusion, we found out actually that according to equation number 1, 2x equals to 5b plus square root of 5 plus square root of 5 times square root of 5 is 5, so it is plus 5 over square root of 5. Here we will divide this equation by 2, and finally we will get that x equals to 5b plus 5 over 2 times square root of 5. This is according to equation number 1. And here we will join points S and M together by a straight line. So in the drawing we have peripheral angle SQM. This peripheral angle SQM is equal to 90 degrees in its size. Repeat again, peripheral angle SQM is equal to 90 degrees in its size. And we have rule number 5 that relates to a peripheral angle that is equal to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So in the drawing we have a circle, inside the circle we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees in size. Therefore, according to this rule number 5, peripheral angle MAN must rest on the diameter of the circle. From the drawing it is very easy to see that peripheral angle MAN rests on chord MN, and therefore according to rule number 5, Mn must be the diameter of the circle. And indeed, it is very easy to see that Mn is the diameter of the circle. Why? Because chord Mn passes through the center of the circle, that is to say, it passes through point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. Okay? So actually, we can implement rule number 5 in our drawing. Why? Because in our drawing, we have peripheral angle SQM equals to 90 degrees inside. Therefore, according to rule number 5, peripheral angle SQM must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle SQM rests on chord MS, and therefore, according to rule number 5, MS is the diameter of the circle. So I write it down. Because of the fact that peripheral angle SQM equals to 90 degrees in its size, according to rule number 5, it must rest on the diameter of the circle. And because of the fact that peripheral angle SQM rests on SM, therefore SM must be the diameter of the circle. SM is the diameter of the circle. And we know that the radius of the circle equals to x according to our definition. Therefore, the diameter SM must be equal to 2x. So write it down. The diameter SM must be equal to 2x units in its length. Okay. In the next step, we will copy triangle SQM in a new page and we will implement on this triangle SQM the Pythagoras theorem. Side QS equals to 5 units in its length, and side QM or the right triangle is QM. QM in total equals to QC plus CM. That is to say, QM equals to QC, that is 5, plus CM, that is B. So in total, QM equals to 5 plus B. So you can write down that side QM equals to 5 plus B, and QS equals to 5 units. And we just right now found out that the diameter SM, it is actually also the hypotenuse of the right triangle QSM, and we know that the diameter SM equals to 2x. Yeah, the diameter SM, that is also the hypotenuse of the right triangle QSM, equals to 2x units in its length. So here, by PT is a variation from Pythagoras theorem. So according to the Pythagoras theorem, SM square equals to QS square plus QM square. This is equation number 2. So according to equation number 2, we found out that SM square, SM is 2x, therefore SM square is 2x squared, and it is equals to QS square. QS is 5, therefore QS square is 5 squared, that is 25. plus qm squared. Qm is 5 plus b, therefore qm squared is 5 plus b squared. So actually, according to equation number 2, we found out that 2x squared equals to 25 plus 5 plus b squared. This is according to equation number 2, while according to equation number 1, we have only found out that x equals to 5b plus 5 over 2 times square root of 5. Now we can substitute x in this equation number 2, by the value that we found for x in equation number 1. According to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Okay, so we substitute x in equation number 2 by the value of x that we found in equation number 1. So according to equation number 2, we have 2x squared. So it is 2 times x according to equation number 1 is 5b plus 5 over 2 times square root of 5 squared. It's 2x squared. This is x, so it is 2x squared. And 2x squared according to this equation number 2 equals to 25 plus 5 plus b squared. We focus on this side of equation number 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. What is left from equation number 2 after we cancel 2? In this side of equation number 2, we have 5b plus 5 square over square root of 5 square. Square root of 5 square is 5. So total this expression after we cancel 2 equals to 5b plus 5 square over 5, and it is equals to 25 plus 5 plus b square. Here we will open the brackets on both sides of this equation number 2, and find out that according to equation number 2, in this side of equation number 2 we have 5b plus 5 squared. 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b, that is 10b, and 10b times 5 is 50b. All divided by 5. So actually, in the conclusion, found out that after we open the brackets on this side, equation number 2, we have here 25b squared plus 25 plus 50b over 5, and it is equals to 25 plus 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b, that is 10b. So on the other side of equation number 2, we have in total 25 plus 25 plus b squared plus 10b. In this side of equation number 2, we have 25b squared over 5 is 5b squared, plus 25 over 5 is 5, plus 50b over 5 is 10b. And it is equals to 25 plus 25 is 50, plus b squared plus 10b. So here we have 10b on both sides of the equation, so 10b will get cancelled. So after we cancel 10b, in this side of equation number 2 we have left with 5b squared plus 5, that is equals to, on the other side of equation number 2, after we cancel 10b, we left only with 50 plus b squared. So here we subtract b squared from this equation, equation number 2, and we get that according to equation number 2, 5b squared minus b squared is 4b squared, so in total this side of equation number 2 we have 4b squared plus 5, that is equals to 50. So here we subtract 5 from this equation, equation number 2, and we get that 4b squared equals to 50 minus 5 is 45. So found out that according to equation number 2, 4b squared equals to 45. Here we divide this equation, equation number 2 by 4. And finally, we get that according to equation number 2, b squared equals to 45 over 4. So according to equation number 2, b squared equals to 45. 45 is 9 times 5, so we substitute 45 by 9 times 5 over 4. Here we take a root out of this equation, equation number 2, and we get that according to equation number 2, b equals to the square root of 9 times 5 over 4. So b equals to the square root of 9 is 3 over the square root of 4 is 2. So inside the root we left only with 5. In conclusion, we found out actually that according to equation number 2, b equals to 3 times square root of 5 over 2. So I copy it again. According to equation number 2, I actually found out that b equals to 3 times square root of 5 over 2. This is according to equation number 2, while according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Now we can put the value of b from equation number 2 here in equation number 1. We know that b equals, according to equation number 2, b equals to 3 times square root of 5 over 2. So we can put the value of b here in this equation, equation number 1. And we get that according to equation number 1, x equals to 5b, and according to equation number 2, b equals to 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. So according to equation number 1, x equals to 5 times 3 is 15. So in total, this expression equals to 15 times square root of 5 over 2 plus 5 all divided by 2 times square root of 5. So according to equation number 1, x equals to 15 times square root of 5 over 2 plus 5. Here we multiply 5 by 2 and then we divide it by 2 in order to common factor with this expression. So it is plus 5 times 2 is 10, and then we divide it by 2, so we change nothing, all divided by 2 times square root of 5. So here we remove 2 times square root of 5 to the denominator, and we get that according to equation number 1, x equals to 15 times root of 5 over 2 plus 10. So it over 2 times root of 5. We moved 2 times 5 here to the denominator. So in total, actually, we found out that according to equation number 1, x equals to 15 times root of 5 plus 10 over 2 times 2 is 4, so in total in the denominator we have 4 times root of 5. Here we substitute 10 by square root of 5 times root of 5 times 2. Okay? And we get that x according to equation number 1 x equals to 15 times root of 5 plus 10, and 10 is square root of 5 times root of 5 over so 10 is square root of 5 times root of 5 times 2, all divided by 4 times root of 5. Repeat again. According to equation number 1, we actually found out that x equals to 15 times root of 5 plus root of 5 times root of 5 times 2 over 4 times root of 5. In the next step, we take root of 5 as a common factor out of those two expressions in the numerator, and we get that according to equation number 1, x equals to the square root of 5. So what is left from square root of 5 times 15 after we took from it square root of 5 is a common factor? What is left? It is actually 15 plus square root of 5 times root of 5 times 2. So what we took square root of 5 as a common factor. So what is left from square root of 5 times root of 5 times 2 after we took from it square root of 5 as a common factor? What is left? It is actually square root of 5 times 2. All divided by square root of 5 times 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally, we found out that x is the radius of the semicircle, the radius that we are looking for, equals to 15 plus 2 times square root of 5 over 4 units. In terms of numbers, x equals to 4.8680 units. Repeat again. The radius x of this semicircle equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the length of the radius x of this semicircle is equal to 4.8680 units, that is a little bit less than 4.9 units. Okay, so in the next step I will summarize the lecture. In this lecture we found out the radius of this semicircle. So in the drawing we have a semicircle. We have line segment PA that is tangent to the semicircle here at point A. We also know that the length of this line segment PA is 6. We also know that the length of line segment PQ equals to 4 units. And we have line segment PS that cuts the semicircle at points Q and S. In addition, we know that this angle PAB equals to 90 degrees in its size, and this is angle SQC that is also equals to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. So first of all, I presented to you a new rule, and we implemented the new rule in our drawing. The new rule is rule number 10. According to rule number 10, if we have a circle and a common external point, point P is the common external point in relation to this circle, and from the common external point, point P, we draw tangent PT, that is tangent to the circle at point T, and we also draw tangent line segment PB that cuts the circle at points A and B. So in this drawing, the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule number 10 in our drawing. Why? Because in our drawing, we have the common external point, point P. From the common external point P, we have tangent PA that is tangent to this semicircle at point A, and we also have line segment PS that cuts the semicircle at points Q and S. So actually, all the requirements of rule number 10 are satisfied, they are met. Therefore, we can implement here rule number 10. According to rule number 10, the following equation will be true, that PA squared equals to PQ times PS. Again, PA squared equals to PQ times PS. Repeat again, if you focus on the common external point, point P, according to rule number 10, PA squared equals to PQ times PS. PA is 6, therefore PA squared is 6 squared, that is 36, plus, and it is equals to PQ. PQ is 4 times PS. What is the length of PS? PS in total equals to PQ plus QS. That is to say, PS equals to PQ, that is 4 plus QS. So in total, PS equals to 4 plus QS. Here, PS is 4 plus QS. So in conclusion, we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we divided this equation by 4, and we found out that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtracted 4 from this equation, and finally we found out that QS equals to 9 minus 4, that is 5. Here, this line segment QS equals to 5 units in its length. But because of the fact that it is given us the question that QS equals to QC, and QS equals to 5, therefore QC must be also equal to 5 units in its length. Then I presented to you rule number 3, and we implemented rule number 3. Okay, again, that QS equals to 5 units. Then I presented to you rule number 3, and we implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So we have in the drawing the straight line AB. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? we have this angle alpha and the other angle beta. So in total, alpha plus beta must be equal to 180 degrees according to this rule, rule number 3. You can actually implement rule number 3 in our drawing. Why? Because if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. Therefore, the missing angle must be equal to 90 degrees. Again, in order to complete the sum of the angles in the lower side of PS at point Q to 180 degrees, the missing angle must be equal to 90 degrees. Then we join points P and C together by straight line. By joining points P and C, we create the right triangle PQC. So I copied the right triangle PQC in a new page and we implemented on this right triangle PQC the Pythagoras theorem. This is the right triangle PQC that I copied from the original drawing. PQ equals to 4 units in its length according to what is given in the question. We have already found out that QC equals to 5 units. Here by PT is a information for Pythagoras theorem, so according to the Pythagoras theorem, the right triangle PQC, PC square equals to PQ square plus QC square. So PC square, that is the square of the hypotenuse, equals to PQ square. PQ is 4, therefore PQ square is 4 square, that is 16, plus QC square. QC is 5, therefore QC square is 5 square, that is 25. So in total, we can actually find out that PC square equals to 16 plus 25, that is 41. Again, the square of the hypotenuse of the right triangle PQC, PC square equals to 41. Then I copied the right triangle PAC in a new page and we implemented in this right triangle PAC the Pythagoras theorem. Actually, this is the right triangle PAC that I copied from the original drawing. This angle equals to 90 degrees, of course, according to what is given as the question. Side PA equals to 6 units according to what is given as the question. In the right triangle PAC, according to the Pythagoras theorem, PC square equals to PA square plus AC square. We have already found out that PC square equals to 41. Here, PC square equals to 41. So we can substitute PC square by 41 and it is equals to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. In conclusion, we found out that 41 equals to 36 plus AC square. Here we subtracted 36 from this equation. And finally we found out that AC square equals to 41 minus 36. 41 minus 36 is 5. So AC square equals to 5. We took out all of this equation and finally we found out that AC equals to the square root of 5 units. Okay, here this side AC equals to the square root of 5 units in its length. So we can write down in the original domain that this 97 AC equals to the square root of 5 units in its length. So it is given us the question that this is a semicircle, and for that reason AB must be the diameter of the semicircle. Okay, AB is the diameter of the semicircle. So if we define the radius of this semicircle as x, if the radius is x, then the diameter must be equal to 2x. So the diameter AB must be equal to 2x units in its length. Okay? So what is the length? What is the length of line segment CB? From the drawing it is very easy to see that CB equals to AB minus AC. Again, AB minus AC equals to CB. So repeat again. CB equals to AB minus AC. AB equals to 2x, it is the diameter of the circle, and we just right now found out that AC equals to the square root of 5 units. So in total, CB equals to 2x minus square root of 5 units. So I can write down in the original drawing that this line segment CB equals to 2x minus square root of 5 units in its length. Then we completed the semicircle to a circle, and we extended side QC by a straight line until it touches the circle. We define the touching point of the extended side QC in the circle as M. Then I presented to you a new rule, and we implemented the new rule in our drawing. The new rule is about two chords that intersect with each other inside the circle. Repeat again on rule number 11. In any circle, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Again, we have chord AB that intersects with chord CD at point O. So whenever you have two chords that intersect with each other inside the circle, then the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule number 11 in our drawing. Why? Because in our drawing, we also have two chords that intersect with each other. Here, chord AB intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. Again, whenever we have two chords that intersect with each other, we can implement rule number 11. So we can implement rule number 11 in our drawing. And repeat again. In our original drawing, chord AB intersects with chord QM at point C. Therefore, according to rule number 11, AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. Repeat again, according to rule number 11, AC times CB equals to QC times CM. AC is square root of 5, CB is 2x minus square root of 5, QC is 5, and according to our definition, CM equals to B. Here, CM equals to B according to our definition. So it was found out that according to rule number 11, AC times CB equals to QC times, square root of 5 times 2x minus square root of 5 equals to 5B. This is according to equation number 1. Here we divided this equation number 1 by square root of 5, and we found out that 2x minus square root of 5 equals to 5b over square root of 5. Here we added to this equation number 1 square root of 5, and we found out that according to equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. Here we multiplied square root of 5 by square root of 5, and then we divided by square root of 5 in order to have a common factor with this expression. And we got actually 2x equals to 5b over square root of 5 plus, again we multiplied square root of 5 by square root of 5, and then we divided by square root of 5, so we changed nothing. Therefore this operation is allowable. And finally we found out actually that 2x equals to 5b plus square root of 5 times square root of 5 is 5 divided by square root of 5. Again, 2x equals to 5b plus 5 over square root of 5. Here we divided this equation number 1 by 2. And finally we found out that according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Then we added, we joined points S and M together by a straight line. In this way we get actually peripheral angle SQM. This peripheral angle SQM equals to 90 degrees. If peripheral angle SQM equals to 90 degrees. And therefore we can implement here rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So here in the drawing we have a circle. Inside this circle we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees in size. Therefore, according to this rule number 5, this peripheral angle MAN must rest on the diameter of the circle. For the domain itself, it is very easy to say that indeed peripheral angle MAN rests on the diameter of the circle. Why? Because peripheral angle MAN rests on chord MN. And MN is indeed the diameter of the circle. Why? Because chord MN passes through point O, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. So because of the fact that peripheral angle MN equals to 90 degrees, for that reason, this peripheral angle MN rests on the diameter of the circle. MN is the diameter of the circle. So according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So we can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle SQM that is equal to 90 degrees. Therefore, this peripheral angle SQM must rest on the diameter of the circle. From the drawing itself, it is very easy to say that peripheral angle SQM rests on SM or chord SM. And therefore, according to rule number 5, chord SM must be the diameter of the circle. Repeat again, because of the fact that peripheral angle SQM equals to 90 degrees, therefore according to rule number 5, peripheral angle SQM must rest on the diameter of the circle. From the drawing, it is very easy to see that peripheral angle rests on SM, therefore SM must be the diameter of the circle. We know that the radius of the circle is x, therefore the diameter SM must be equal to 2x. Okay? Then I copied and the right triangle QSM in a new page and implemented the Pythagoras theorem in this right triangle QMS. This is the right triangle QMS that I copied from the original drawing. Side QS equals to 5 units and QM equals to QC plus CM. That is to say, QM in total equals to QM that is 5 plus CM that is B. So in total, QM equals to 5 plus B. Here, QM equals to 5 plus B and QS equals to 5. The hypotenuse of this right triangle SM equals to the diameter of the circle, that is actually 2x according to rule number 5. So in this right triangle SQM, according to the Pythagoras theorem, SM square equals to QS square plus QM square. Again, SM square equals to QS square plus QM square. SM equals to 2x, therefore SM squared is 2x squared. And it is equals to QS square. QS is 5, therefore QS square is 5 squared, that is 25. Plus QM square. QM is 5 plus B, therefore QM square is 5 plus B squared. So actually, in total, according to equation number 2, we found out that 2x squared equals to 25 plus 5 plus b squared. This is according to equation number 2. But according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times root of 5. So now we can substitute x in this equation number 2, by the value that we found for x in this equation number 1. Okay? So we did it here and found out that according to equation number 2, 2x squared we have. So it is 2 times x squared. And x according to equation number 1 is 5b plus 5 over 2 times root of 5 squared. Because it is 2x squared. And according to equation number 2 it is equals to 25 plus 5 plus b squared. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So this expression after cancel 2 equals to 5b plus 5 squared over square root of 5 squared. Square root of 5 squared is 5. So in total this expression equals to 5b plus 5 squared over 5. And it is equals to 25 plus 5 plus b squared. So here we open the brackets on both sides of the equation number 2, and found out that according to equation number 2, 5b plus 5 squared equals to 5b plus 5 squared equals to 5b squared. 5b squared is 25b squared plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b. So in total, in the denominator in this side of the equation, we have 25b plus 25 plus 50b, all divided by 5. Is divided by 5. And in the other side of equation number 2, we have 25 plus 5 plus b squared. 5 plus b squared equals to 5 squared, that is 25, plus b squared, plus 2 times 5b, that is 10b. So on the other side of equation number 2, in total we have 25 plus b squared plus 10b. So 25b squared over 5 is 5b squared. 25 over 5 is 5, and 50b over 5 is 10b. And it is equals to 25 plus 25 is 50, plus b squared plus 10b. So here we have 10b on both sides of the equation, so 10b will get cancelled. So on this side of the equation, after cancel 10b, we left only with 5b squared plus 5. On the other side of the equation, after cancel 10b, we left only with 50 plus b squared. So in conclusion, according to equation number 2, we found out that 5b squared plus 5 equals to 50 plus b squared. Here we subtracted b squared from this equation, equation number 2, and found out actually that 5b squared minus b squared is 4b squared. So in total, on this side of the equation, we have 4b squared plus 5, that is equal to 50. So 4b squared plus 5 equals to 50. We subtracted 5 from this equation, and finally found out that 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45. Here we divided this equation, equation number 2, by 4, and finally found out that b squared equals to 45 over 4. So b squared equals to 45. 45 is 9 times 5, all divided by 4. Here we take a root out of this equation, equation number 2, and finally found out that b equals to the square root of 9 times 5 over 4. So b equals to the square root of 9 is 3, and over 4, and the square root of 4 is 2. So inside the brackets, inside the root, we left only with 5. So in total, actually, we found out that b equals to 3 times square root of 5 over 2. Fitting in, we actually found out that according to equation number 2, we found out that b equals to 3 times square root of 5 over 2. So we have the value of b in terms of numbers. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Now we can put the value of b from equation number 2 inside this equation number 1. Because we know the value of b in terms of numbers. We did it and we found out actually that x equals to 5b and b equals to 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. So it is 5 times 3 is 15. So in total this expression equals to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. So here we multiplied 5 by 2 and then we divided by 2 in order to have a common factor of this expression. So in total we actually found out that x equals to 15 times square root of 5, and 5 times 2 is 10 divided by 2. So we multiplied 5 by 2 and we divided by 2, so we change nothing. So it is 5 times 2 is 10 over 2, all divided by 2 times square root of 5. So here we moved 2 times square root of 5 to the denominator here, and we found out that x equals to 15 times square root of 5 plus 10 times, in the denominator we will have 2 times 2 times square root of 5, because we moved 2 times square root of 5 to the denominator. So in total in the denominator we have 2 times 2, that is 4, so in total in the denominator we have 4 times square root of 5, and therefore x equals to 15 times square root of 5 plus 10 over 4 times square root of 5. Then we substitute 10. We substitute 10 here by square root of 5 times square root of 5 times 2. And we found out actually that x equals to, according to equation number 1, x equals to 15 times square root of 5 plus 10, and 10 is square root of 5 times 2, all divided by 4 times square root of 5. Then we took square root of 5 as a common factor out of those two expressions in the numerator. So square root of 5 is taken out as a common factor. What is left from 15 times square root of 5, so we took from its square root of 5 as a common factor. What is left is actually 15. And what is left from square root of 5 times square root of 5 times 2 after we took from its square root of 5 as a common factor? What is left is actually square root of 5 times 2. All divided by square root of 5 times 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator. So square root of 5 will get cancelled, and finally found out actually that x equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, x equals to 4.6860 units. I repeat again, x, that is the radius of this semicircle, equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle, the radius that we are looking for, is equals to 4.8680 units, that is a little bit less than 4.9 units. Okay, thank you very much.